This
Now,
conference will now be recorded.
we discussed about the introduction part as well as the installation process of Keel software. Okay, today let me go with this Proteus 8. Yes. If you have any doubts, you can respond in chat box. I'll read every question which you posted in the chat box. Okay. Let me start with the installation process of Proteus 8. Okay, if anybody do not download that Proteus 8, try to download the software. I'm going to share the link for you. Okay, fine, control V. So open that link. Okay, guys, if you open that link and you'll get a page like this. Keel mdk410.exe Proteus 8 with the crack version. Right click on this and download this. Okay, download this folder and you will get a zip file. Okay, the downloaded file will be in zip file and try to extract the zip file. Right click on the zip file and click on that extract button. Try to do it. Okay, after completion of this both the softwares and we'll jump into the like tasks. Okay, basic tasks. Guys, are you following? Can you please respond what I am saying? Are you following or like I want to repeat it again? I shared the drive link for you. Open the drive link, download Proteus 8. Right click on the Proteus 8, you'll get a download option, download it and you'll get a zip file. Try to extract the zip file. Okay, extract the zip file. From there I'll tell you the installation process. Guys, don't do as your own. If you are aware of that, it's okay. If you do not know about that, just let's go slow way. Okay, yes guys, this is the installation process. If you are done with that download, I'll start the installation process. Okay, please make it fast, guys. That's better to uh, uh, like whether you are following or not, please respond in chat box. Okay, still downloading. Okay, yes, whatever the download file will be in zip format, extract that and you'll get a folder like this, Proteus 8 full with crack working. Okay, if you extract that, you'll get like this, Proteus 8 full with crack working folder. Okay, from here I'll explain you how to install the Proteus 8. Everybody is doing. Guys, who do not have laptops, can you please respond in chat box? Who are not having laptops? Mm. Okay, I have no. Okay, no problem. No problem. Uh, you can follow the class. No problem. No problem. But whoever having the laptops, try to do parallel along with me. Okay, it will be helpful for you. Mhm, mhm. No problem. No problem. But whoever having the laptops, you can go ahead with the software Proteus 8. Okay, it will be helpful in your future also. Guys, have you downloaded it? Have you extract the file? Can I continue the class? Can you please respond? If you say yes, I'll continue the class. I mean that I'll tell you the installation process of Proteus 8. After extracting the zip file, you'll get a Proteus 8 full with crack working. Okay, just remember this: Proteus 8 full with crack working. So what do you do? So actually, this is a hardware part. Proteus 8 is a hardware part. Okay, we are going to design uh, whatever the task we want. Okay, like there are so many. Like we can go ahead with so many microcontrollers will be there. Almost so obviously, embedded system is a combination of hardware and software, right? So for software, we are going to use this Kill software. For hardware part, we are going to use this Proteus 8. Okay. After installing this, after opening this, after designing the hardware part, you'll get a clear idea about what is the use of this Proteus 8. There's at least one have downloaded it. Have extracted the file. Have extracted the zip file. At least one. In yesterday's class, there are around 9 members. So that I hope they are all done with that. If you do not do that, please respond. If you are done with that, please respond. At least respond, guys. Yeah, yeah. Yes. Can I continue the class? Can I go ahead with this installation process of Proteus 8? Can I go ahead? Yes. Fine. Because it's all around 10:20. I'm going to continue this installation process of Proteus 8. Guys, after extracting the file, zip file, you'll get a folder like this: Proteus 8 full with crack working. Open that folder. Okay, you'll get a crack setup. Okay, sometimes you'll get a license key here only. Okay, try to click on this setup. Okay, click on this setup. I'm going forward, guys. Don't I mean that in the middle of the class, don't ask me to come back. Okay, so that's the reason I have given the time for you. Fine. Open this Proteus 8 full with crack working. Open that folder. You'll get a crack setup. Okay, so click on this setup. You'll get a folder like this: Welcome to Proteus 8 Professional Setup Wizard. Okay, So after this click on next. So read the lab center electronics license terms. Fine. So here there is a single user license. Accept this. Okay, I accept the terms of this agreement. Okay, accept this, click on next. Accept this, click on next. Fine. And next step is like you'll get a folder like this. Setup type, use a locally installed license key. Select this, use a locally installed license key. Select this. Yeah, I'll send you the recorded class after this. By evening I'll send you the recorded class. Okay. Choose. Okay, here you have to use the locally installed key. Locally installed license key. Select that, click on next. Okay, you'll get a page like this. Product license key, no license key found for Proteus. Click next to install one. Okay, click on next. You'll get a page like this. Okay, if you get the page like this, browse for key files. Find all key files will be there. Try to browse, click on browse for key files. Okay, obviously you'll get a folder. I mean that you can go to this Proteus 8 full with crack working. Open that folder, open the crack. Okay, if you open the crack, there should be a license key. I'll show you that. Okay, after clicking on this browse for key files, okay, open your Proteus 8 full with crack working and open that. If you open this crack, okay, you'll get a license key. Okay, double click on this, open that, select that and open that. Okay, you'll get all the license key here. Okay, all the keys will be pasted here. Fine. Have you done up to here? Is it okay for you up to here? Are you following? Please respond in chat box. Up to here, are you following? Guys, I want to know whether you are following or not. Please respond. Yes. Yeah. Okay, all the license key will be pasted here. Okay, click on install. Okay, there are browse for key files, find all key files. Next install button is there. Try to click on install. Okay, try to click on install. Okay, you'll get a page like this after clicking on the install. Okay, do you wish to continue? Yes. Okay, if you click on yes, you'll get a page like this. You'll get a page like this and close this. Okay, close this. After that you'll get a page like this. Proteus 8 professional setup, import legacy styles, templates and libraries. So Anish sir, can you please respond for that? Fine. Import legacy styles, templates and libraries. Okay, after this
Actually, sorry for that. 1 minute, Shankar.
sure.
It's not a faculty development program. Please, we will conduct it later. So join for that. Okay, it's for students only. Okay. Okay, sir. Thank you for your reply. Okay, continue, Shankar.
Yeah. Okay, after clicking on this close button, close, and you'll get a page like this. Import legacy styles, templates and libraries. Okay, try to select all these like boxes like merge styles from previous version, import templates from, select all these three, click on next. Okay, select all these three, click on next, and choose the installation you want. Okay, click on typical, choose the installation you want. Select the typical. Okay, Click on the typical. Obviously, if you select on the typical, the installation progress, you'll get a page like this. If you got this, you are in the right way. Okay. After completing, I mean that if it completes to 100%, in backdrop or like you'll get a page like this, guys. Remember this. Okay. If it reaches to ending point or if it reaches to 100%, you'll get a page like this in backdrop, like legacy settings importer. Okay. Do this up to here. Do this up to here. If you are done up to here, I'll continue. Yes. So can I go forward? Can I go forward? Yes, done. Yes, good. Okay. So if you are done up to here, if you got this page legacy setting importer, cancel that. Cancel that. Try to cancel it. Okay. No need to do anything. Cancel that. Cancel. Click on the cancel and open your Proteus 8 crack working. Open your Proteus 8 crack working. Okay, here I'm going to tell you some steps. Open your Proteus 8 crack working and open your crack. In crack, there is a bin folder. Guys, these are the 4 steps is there here. Please do follow that. Open your Proteus 8 full with crack working. Open your crack. In that crack, there is a bin folder. Open the bin folder. Try to copy all the files. 5 files or maybe 4 or 5 files will be there. Try to copy all the 5 files. Okay, copy all the 5 files or 4 or 5 files. Okay, copy it and open your Windows C. Okay, open your Windows C or local disk C, or you can, okay. In that Windows C, there is a program file x86 is there for you. See here, there is a page for you. Okay, after copying all these things, open your Windows C. In that program files x86 folder will be there. Just do follow what I said. Copy that files which are there in the bin folder. Open your Windows C. In that program files x86 folder will be there. Okay, open that program files x86. There you'll get a folder called Lab Center Electronics. Lab Center Electronics. Fine. Open that Lab Center Electronics. Open the bin folder. Okay, if you open that, you'll get a bin folder. Open the bin folder. There are so many files will be there. Try to paste the files, whatever the copied files are there. Whatever the files you copied there in bin folder, try to paste it here. If you paste it here, it will ask like this: replace or skip files. Click on the replace the files in the destination. You have to replace the files whatever you copied there. Okay, click on this, replace the files in the destination. Okay, after doing this, obviously I'm just showing you that you'll get a icon like this, Proteus 8 professional. Before opening it, don't try to open this. After doing this, guys, where it is, fine, it's here. After replacing the files in the destination, don't try to open it. Try to close whatever the folders you opened. Try to close everything which you opened regarding the software or anything. Okay, after that, double click on this Proteus 8. You'll get an icon like this. Close everything what you opened. You'll get a page like this, untitled Proteus 8 professional home page. Okay guys, here I'll show you one thing that I just marked it here, that if you clearly observe this, ISIS should be in blue color. If ISIS is in blue color, you are completed in the right way. You are done with this Proteus 8. The Proteus 8 is installed clearly. Okay, the ISIS should be in blue color. I highlighted here also. Okay, so have you done with this or not? Okay, you'll get a page like this. This is Proteus 8 professional home page. Is it completed or not? Is it? Yes. Is it completed? Have you done with this? If this ISIS should be in blue color, you install this Proteus 8 successfully. Okay, yes, thank you. This is all about this software's installation of Proteus 8 as well as Keel. Okay, this is called Proteus 8, and this is called Keel Microvision 5, which I downloaded it and installed it in yesterday's class. By using these softwares, we are going to do a basic tasks for today. Clear? Okay, fine. If you are done with this, I'll continue. If you are done with this, I'll continue. Please respond in chat box. Yes, as I'm continuing the class, I'm going forward. Okay, so guys, we are done with this skill. Yes, we are done with the skill Microvision 5 as well as Proteus 8 professional, which is used for hardware part as well as software part. The basic tasks. Okay, try to connect the LED for microcontroller. What will happen? Let's see first of all. Okay, try to connect the LED. Okay, the hardware part, we are going to use this Proteus 8. Open your Proteus 8. Okay, after opening this Proteus 8, I'm telling you that I'm going to connect the LED for microcontroller 8089C5, and this is our microcontroller. Okay, let me see what happens. Fine. So after opening this page, click on this new project. Click on this new project. You'll get initializing the project wizard. Okay, so guys, here you'll get a name path. Okay, so try to change the name only new project. In place of new project, you can type LED. If you want to replace with that your name also. Okay, it's your wish, whatever the name you want to give for that. Okay, led.pdsprg. So don't try to remove that. Okay, .pdsprj. Okay, so led dot some name. Click on next. Click on next. This is all a very easiest process. Click on finish. So you'll get a page like this. You'll get a page like this. Fine. Now you must have to click on ISIS. Okay, click on this ISIS. Fine. So if you observe left side top, if you observe LED slash like a dash Proteus 8 profession. Okay, it means that whatever the project name you have given there, replaced with LED. Right. So guys, if you observe here, okay, this is a process what we want to do for a hardware part, hardware design. Okay, left side there is a P and L devices are there, right? If you are getting my mouse, it will be very clear for you, like a P and L devices are there. P is called pick the device. Oh, once again open the once again for open file. What is that? I can't get you. Okay, guys, is it okay up to here? Is it okay up to here? Can I go forward? If you have any doubts, you can ask me now. Okay, left side you'll get P and L devices, where P is called pick the device, L is called list of the device. P is called pick the device, L is called list of the device. And here there are some symbols like terminal modes, sub-circuit modes, active pop-up modes, everything will be there. Right side, I mean that left side corner. Okay, component modes, selection modes, everything will be there. But we will see all these things later. And try to open this P, pick the device. Pick the device. Click on this P. Whatever the microcontroller we want, type it. Okay, AT89C51. This is our microcontroller, right? This is what we discussed yesterday class. Okay, in 8051 microcontroller families, we are going to use one particular microcontroller called AT89C51. This is our microcontroller. Okay, guys, if you type AT89C51, you'll get so many microcontrollers are there. There, AT89C51. Okay, double click on this. You'll get our microcontroller AT89C51. Double click on this, or like you can click on OK. Right side bottom, click on OK. Fine. So our microcontroller is placed here, AT89C51. Again go to P, type LEDS. LEDS. So here if you observe, LED blue, LED green, LED red, LED yellow. Okay, try to use this for only. Okay, don't try to use this animated bicolor LED models. We can use that, but we'll go ahead with this. Okay, so LED blue, LED green, red or yellow. In these four colors, you can use any color, whatever you prefer. Okay, I'll go with blue. Okay, double click on this. Double click on this or click on OK. Okay, the LED is selected. Now select your microcontroller. Okay, click on your microcontroller. Just left click on this. In whatever the place you want to place this microcontroller, you can place it there. Okay, I'll place it here. Let me zoom this. It will be clear for you. Okay, again click on this LED. Guys, I said you, and we discussed about the pin description of I mean that pin diagram of 8051. Like there are 4 ports. Obviously 3 ports are active high ports, like port 1, port 2, port 3 are active high ports. Port 0 is active low port. So I'm going to use high ports like 2, 3 or 1, port 1 or port 2 or port 3. Okay, you can connect this LED for any of these 3 ports only. Don't try to connect for port 0 because it is an active low port. Okay, if you connect LED to for port 0, you need to connect the power supply externally. So okay, let me go ahead with this. Okay, as my comfort, I'll take port 2. It's your wish, guys. It's your wish to take port 2, port 3 or port 1. You can change your ports also. Fine. So I'm going to connect this. What is an anode port and what is a cathode port? Obviously this is an anode port which is connected to the power supply, and cathode should be grounded. Guys, left side, if you go ahead, there is a terminal mode. Okay, there are so many symbols I said you. So there is a terminal mode. Okay, click on this terminal mode. There is a ground. You should connect the ground for the cathode. Okay, place this ground a little bit far to this cathode. Okay, don't try to connect directly to the cathode. Don't try to connect this ground directly to the cathode. Try to place it a little bit far. Okay, fine. This is our connection. Okay, let me run this. What happens? what happened? So obviously LED is in high state. So guys, what is the reason behind it? What is the reason behind it? Guys, you have to respond. You have to respond, because I hope every concept and everything which I'm saying is very clear for you. What is the reason why LED is in high state? It means that LED is in on. What is the reason behind it? Because actually it's a combination of hardware and software without writing any code. I have not written any code for it, but LED is in on state. What is the reason? You got my point, right? So it's a combination of hardware and software. Whatever as per the logic, you have to write the code, and the code should be dumped into this microcontroller. But I have not written any code, I have not dumped anything, but I connected the LED directly to the microcontroller. If I run this in the Proteus site, the LED is on. What is the reason? Please respond. What is the reason? Anybody? గైస్ ఉన్నారా లేదంటే ఫోన్ పక్కన పెట్టి నిద్రపోతున్నారా? అర్థం కావట్లేదు. సో ఇఫ్ దేర్ ఈస్ a discussion when we give low voltage, okay, where we have given the low voltage? Port. By default all the outputs should be high. Okay, so is there any particular reason that default that's okay, defaultly all the outputs should be high? Some pins are activated because anode is connected to positive supply and cathode is connected to ground. Okay, so actually guys, 5 volts DC power supply will be there in 805 microcontroller. That's what we discussed in yesterday class, right? So obviously if you run here, all these 3 ports are high. It means that 5 volt supply is going to pass by these ports only, like 2, 3 and 1. So that's the reason they all are in high state, like red. If you observe this, there is a power supply, right? So that's the reason, without writing any code, obviously there is a 5 volts DC power supply will be there in 805 microcontroller. So that's the reason automatically, without writing any code, the LED becomes on. Fine, I hope you got my point, right? 5 volts DC power supply will be the internally inbuilt in this 805 microcontroller. That's what we discussed in yesterday class in hardware part. Okay, so obviously if you run the Proteus, if you run this in Proteus, there is a 5 volts DC power supply will be there. Automatically the LED will become on. Okay, now let me make this LED off by using a code. Okay, without writing code we can't make this LED off while we are running a Proteus, right? Somebody will say that, sir, if you want to stop this LEDs and try to make it stop, it becomes off. So it's not a, you know, let me try this, let me make this LED off while when this Proteus 8 is in working. Okay, if I run this Proteus 8, I should make this LED off. Let me write a code for that. Repeat, sir. Okay, what you do not understand, Sushma? ఏం అర్థం కాలేదో చెప్తే నేను I'll tell you. So LED, so I have taken an LED, anode is connected to port 2, pin number 0. So if you observe here, there are 8 pins, 0 to 7. I connected, if whatever the port, whatever the pin you want to take, you can take it, but you have to take only 2, 3 and 1. Okay, because all these 3 ports only are in high state. Okay, so inbuilt 5 volts DC power supply will be there in 805 microcontroller. This is our microcontroller. Inbuilt 5 volts DC power supply will be there. I just connected LED to this microcontroller. I run this Proteus, the LED becomes on. Obviously there is a power supply, 5 volts DC power supply will be there. So that's the reason, without writing any code, the LED becomes on. అర్థమవుతుందా సుష్మా? So it's not a big deal. Okay, it's a very easiest. Okay, if you observe every port, like there is a symbol of red, right? There is a power supply. Okay, done. So okay, let me try to make this LED off. Let me try to make this LED off by writing a code. Okay, so well, coming back to this code part, let me stop this Proteus 8, open the notepad. Oh, fine. Fine. So guys, I hope you all are aware of this normal C programming, like how to write a code in the normal C language. Before going to that, let me tell you, this is our microcontroller 8089C51. Okay, here 8089 is belongs to Atmel, because Atmel family microcontroller is this. 8089 is Atmel, and C is CMOS technology is used in the fabrication. Okay, where C is called CMOS. Okay, complementary metal oxide semiconductor technology. Okay, complementary metal oxide semiconductor technology is used in the fabrication process. So why this CMOS technology is used in the fabrication process? The only reason is that low power consumption. Okay, by using the low power, you can operate like you can operate the microcontroller. Fine. So where C is a CMOS and 5.1 is a series. Simply, this is a series. Okay, if you are doing 8052, you'll get 52. Okay, this is all about this. Right, clear. Now we'll go ahead with this code part of how to write a code in normal C. Okay, before going to this embedded C, I'll tell you how to write a code normal. Like I just want to print hello world, or I just want to print hello or hi, anything. Okay, how the steps will be there, the format of steps, how the format will be there while writing a code. Definitely there should be some steps, right? First of all, we'll take the header file, then we'll open the main function, then we'll write a printf, like that. One steps will be there, right? So in the same way, in embedded C also there are some steps. Okay, let me go. First of all, I'll write you how we'll write a code in normal C language. Okay, so hash include. So what is this? What is this? Guys, please respond. What is this?
Not audible, sir.
Guys, sorry. Okay, so I make it where I am there. Oh, fine. So this is a header file. Sorry for that. So this is our header file. Hash includes reg51.h. This is a default header file for 8051. Okay. So second step is like hardware declaration or a port declaration. Hardware declaration or a port declaration. Second step. So what is our hardware part? This is our hardware part, right? So we connect the LED for port to pin number 0. Remember this. We connect LED for port 2 pin number 0. If you connect the LED for port 3 pin number 1, this is your hardware part which you want to mention in the second step after header file. Right? Let me open this. So where S bit is called special function registered bit, LED is connected to capital P2 port 2 pin number 1 cap 1. Clear. This is our hardware declaration or a port declaration. Okay, or a port declaration. Clear. This is our second step, right? Next one is, let me open main function. This is our main, void main. Okay, main function. Fine. After writing the main function, we all know that we have to open these braces. We want to make the LED off. Clear. If you want to make this LED off, clear. This is our simple way to write a code. Okay, to make the LED off. To make the LED off. Clear. First one is hardware part, hardware header file, hardware declaration or the port declaration, main function. Obviously, while open, if you open that after opening this main function, try to make this LED off. LED off is equal to 0. Clear. So guys, remember this REG, registers. Remember that. So microcontroller works on the registers. Microcontroller works on the registers. So for this registers internally there is a program as like standard input and output. See, for example, whatever the input you want to give in a normal C language, you have used the standard input and output header file. For this standard input and output header file, there is a program internally. Okay, so how can a microcontroller knows that what you have given? Okay, everything will be stored in the registers only. Okay, this is the header file. Microcontroller works on the registers. Remember this. So S bit is a special function registered bit. It means that I am taking in this registers, I am taking only one pin, like port to pin 1. If I want to take total port 2, so I'll write it like this, like has defined port 2. Simple. I'm defining that. I'm defining hardware part as port 2 simply. If I want to take only one pin from port 2, you have to type S bit. S bit means special function registered bit. LED is connected to port to pin number 1. Obviously main function. Open that, LED makes off. Clear. This is our how to make this LED off. Okay, try to open the key. Try to open the key. Okay, open this key. So guys, if better to better to write the steps. Better to write the steps. The steps are little bit of complex. How to write a code in this key. Okay, before going to that, it's better to create one folder, new folder. Better to create one new folder. Okay, so in this skill the path is most important. The path is most important. The microcontroller will choose the path. I'll show you everything. The path is most important, where you place the code. Okay, fine. Try to choose, try to create one new folder. Okay, after opening this skill, follow the steps carefully. Follow the steps very carefully. That file, edit, view, project, flash, debug, peripherals, tools, SVS, so many are there, right? Here, go to this project. Go to this project, open that new microvision project. You'll get like this, new microvision project. Click on this. Click on this. So actually there is a path for me. Okay, if you click on this new microvision project, they'll ask try to save the file. Okay, I'm going to save this in PC, in desktop, in Keel. Let me open one new folder. Let me open one new folder called LED. Okay, I just created one new folder in the Keel. Guys, path is most important. I'm showing you that the PC, desktop, in Keel. I opened in Keel. I am going to create one new folder called LED. In this LED, I want to save this LED off. LED off. Click on save. So clear. The steps are most important. If you want, better to write it down. Okay. So after saving that, it will ask to select the microcontroller. Search. Type 8089C51. This is your microcontroller. So guys, if you type there, guys, if you are using Proteus, I mean that Keel Microvision 4, okay, you have to go for Atmel. There you have to select 8089C51. Remember this. If you are using Keel Microvision 5, you can directly select 8089C51. Okay, double click on this 8089C51. Click on OK. Clear. It's your wish to type, click yes or no. It's better to click no. It's your wish. There is no problem in that. Fine. So the project is created, target is there. If you click on this left side small plus symbol, okay, source group 1 is there. Fine. Repeat it once. Fine. Where I have to repeat? From starting or like in the middle of this file saving? Fine. Fine, Aditya. Let me close this. Let me open from starting. Guys, the only thing is that we'll get a little bit of confusion at initial positions only. After that, you'll get a clear idea. Okay, we'll go with the task very fast. We'll go with the task very fast. Fine, guys. After opening the skill, you'll get a page like this. Go to the project, click on new microvision project. Okay, here path is most important. Path is most important. In this desktop, I'm going to use skill. Okay, here in this skill, I'm going to create one new folder called LED. Guys, are you getting my point? Path plays a key role wherever the file you want to save. Path plays a key role. Like this PC, and I have chosen the path like my PC, this PC, desktop, in Keel. I create one folder called LED. In this LED, I'm going to save it as LED off. LED off. This is my file name. I saved it in LED. Here, if you observe here, this PC, desktop, Keel, and LED. Clear? And I have taken the file name called LED off. Click on save. Aditya, అర్థమైందా? చెప్పాను మళ్ళీ. Is it clear? Okay. Is it okay for you? Yes. Yes. So again, in the search box 8089C51. Okay, click on type as 8089C51. Double click on your microcontroller, our hero, and click on OK. Okay, select no or yes, no problem, no worries, but better to say no. Okay, in this target left side, you'll get a plus symbol. Click on this. There is a source group 1, but now even though we are not got this space to write a code. Okay, fine. Go to file. Next step, guys, go to file, click on new, again go to file, save it. Okay, so here obviously there will be a path. Try to save it as LED off dot C, extension of C, because we are writing a code in embedded C. so that we need to save it as an extension of .c. .c is mandatory. Fine, save. You'll get a workspace. Now you are eligible to write a code. Before writing a code, go to this source group 1, go to the source group 1, right click on the source group 1, okay, add existing file to group source group 1. Okay, you'll get a third option, add existing file to source group 1. Here directly I'll got an LED off. This is my, click on this, add, close. Fine, fine, clear. Okay, now go to this notepad. This is our code, control C, and pin number 0, pin number 1 I have given. Fine. Open this Proteus coil, try to paste it there. Guys, in this Proteus I used port to pin number 0. Okay, so try to change it here, pin number 0. Fine, void main, LED on, LED off, we closed it. Fine, let me build this, guys. Second option, okay, build F7. F7 is the keyword. If you observe my cursor, build option is there. Build this. Okay, here you'll get 0 errors and 0 warnings. It means that whatever the code you have written there is correct. Whatever the code you have written is there correct. So after this, okay guys, go to this target one. After this, go to the target one. If you do not get any errors, okay, if there is no errors and no warnings, go to this target one, right click on this target one, options for target one, try to change the clock frequency here, 11.0592, what we discussed in the last class. Okay, so go to the output, create hexa file. Microcontroller will take the hexa file only. Okay, create, click on this hexa file. Okay, okay, then again rebuild this. You must rebuild this because here you'll get hexa file is created from the objects. Fine, now I'll go to this Proteus 8, double click on this microcontroller 8089C5 and double click on this. Here it asks to change the clock frequency. Don't change everything, just try to change 2 only. Okay, 11.0592. okay, here program file, there is a folder here guys. This is the path. Okay, so what is my path in desktop, in keel, in LED, in objects, there is a hexa file, LED of dot hex. Click on this, the path is created, click on OK. Now I'll run this. Guys, if you observe, even though there is a 5 volts DC power supply, I make this LED off by using our code. Like as like this only we will do everything, like for motors, for 7 segments, for LCDs, for everything. Okay, I hope it's clear for you. If you are done with this, I'll go forward. Ardhamayinda clear ga. Okay, before that let me take 1 minute because I just want to take the screenshots of this. Guys, give me 1 sec, give me 1 minute. Snipping tools. So from here onwards, let me go a little bit of fast because steps plays a key role, so that I make it very clear for you. Guys, have you done with this? Ardhamayinda. 11th batch or 12th batch? 12th batch. New folder called day 2. Day 2. Just ఏం ఫైల్ నాన్న ఆదిత్య, వాట్స్ ఫైల్? యు ఆర్ ఆస్కింగ్ మీ ద పాత్ అడుగుతున్నావా? You are asking me the path or like something one. Path, fine. I will show it now. I will show you guys. No worries. It's playing with me. Proteus skill is I. Okay. Fine. So let me stop this, guys. Path you have to select in this way. Double click on your microcontroller. This is our microcontroller 8810C7. Come here and double click on this. Okay, program file will be there. Okay, there is a folder symbol. Click on this folder symbol. Okay, go to the desktop. I don't know where you choose the path also. Okay, you have to know about that, where you save the file and where the hexa code is there. Okay, go to this desktop, open the key. In this I said it in this LED, in objects there is a hexa code. Okay, click on okay, and if you run this, the code will run. Fine. Is it okay? Have you done with this or not? Have you done with this or not? Please respond. Yes, please respond. 25 members at least. Whether you followed or not, have you listened or not? If you have any doubts, you can post it in the chat box. I'll respond to your questions. Dharani, Siddhartha, Srikant, Kalpana. Yes, Pavanike. In objects, no files found, sir. In objects, no files found. Fine, everybody got it. Thank you. And Aditya, I hope there is a problem with you. You can check. Okay, fine. So let me make this LED blink. Okay, let me make this LED blink. For blinking, we need delay. Okay, so let me go ahead with the program. Okay, we'll write a code for LED blinking. How it will be, we'll see now. We'll see now. Fine, let me stop this Proteus. Yes, guys, here you'll get a start and stop button, run and stop button. Try to make it stop. Okay, I don't want to change this LED. I don't want to change the pin also. Let me make this LED blink. Now we make this LED off. Let me make this LED blink. Fine. My God. Fine. So LED blinking. This is our task now. Well, what are the steps? Obviously, header. This is our header file. First step is header file. Second step is hardware declaration, or not this or this, or port declaration. This is the second step. Third step is function declaration, because you are going to use delay function. Third step is function declaration. Okay. Fourth step will obviously main function, and fifth step is function definition. Use function defi. This is a fifth step. These are the steps, guys. These are the steps for LED blinking, right? So what is a header file? You have to tell me now. What is a header file? What is a header file? Header file for 8051. Please type it in your chat. Type it in the chat box. What is a header file? reg51.h. This is our header file. Hash include reg51.h. Fine. Second step is hardware declaration. I'll write it here, because hardware declaration. And second step is sorry, so నేను తప్పు రాసి చూస్తా ఉన్నారు. Header file. This is our header file. Header file declaration. Fine. Second step is like hardware declaration. I don't want to change that. I just take it port to pin number 0 only. So S bit LED is connected to capital P port to pin number 0. Clear? S bit LED is connected to port to pin number 0. This is a hardware declaration. Fine. Third step is function declaration. Void delay function we are going to use. This is the function declaration. Clear? Next step is main function. Obviously we all are aware of this main function. It's a very easy coding. Next step is I am going to use while loop. What is the use of this while of 1? Can anybody tell me what is the use of this while of 1? What is the use of this while loop? In main function I'm using while of 1. What is the use? So while loop is used, it acts as an infinite loop, always true. Yes, exactly, it's an infinite loop. Okay, the execution will be for infinite times. Okay, the loop will execute for infinite times. So that's the reason I want to make this LED blink for continuously. So that's the reason why I'm using this while loop as while of 1. Clear? Now I opened it. I'll make LED 1, or I'll make LED off, and we'll give some delay. And my god, as if you are getting any disturbance from my side, please excuse me. Okay, LED, I'll make this LED off, guys. After making this LED off, I'll give some delay, because initially LED should be in off, because 5 volts DC will be there. So that let me make this LED off initially. Okay, LED becomes 0 and I have to give some delay. Again I'll make this LED is equal to 1, which means that LED should on. There we have to give some delay. Fine. Up to here we clear it. So I just want to make, I'll close this main function and while loop. Okay, what is the last step here? What is the last step here? Function definition. Last step is after main function there is a function definition. Okay, so what is our function? Delay function. Okay, so we want to write the void function definition, void delay. Guys, observe this. After writing this function definition, I'll explain you why we are writing this function definition. Okay, I'm going to close, I'm going to open this a function definition. I'm going to take the integers values. I'm declaring the integers values as I comma j. I'll tell you why we are doing all this stuff. I'm going to use for loop for I is equal to 0, I less than 100, increment I plus plus. Okay. In the same way for j is equal to 0, j less than 1000, j plus plus. In embedded C, we want to keep the semicolon because we are terminating this for loop here. Fine, we are ending this. Guys, remember that I hope you all are clear of these 4 steps, like header file, hardware declaration, function declaration, main function. So why we are writing this function definition? So remember that. So as per my knowledge, నాకు అర్థమైంది ఏంటంటే select so many professors, so ఎంతో మంది, so they have given so many conclusions, so many, who is that? Okay, they have given so many like conclusions, so many theories on for this function definition. So many majority will says that definitely this code will convert into hexa code. Okay, in that hexa code, this for loop and for like these 2 loops, like I and j, whatever this 100 value and 1000 value will get multiplied internally. So for 1 second is equal to 10 to the power 6 microseconds. Okay, internally this 100 and 1000 will get multiplied. It almost, the delay will comes almost 1 for 1 second. So many conclusions are drawn by so many. Okay, but as per my, నాకు ఇదంతా వినిన తర్వాత వాట్ ఐ కంక్లూడెడ్, నాకు అర్థమైంది ఏంటంటే, so we are writing this delay definition only to give some delay, that's it. సో ఇక్కడ మనం ఒక న్యూమరికల్ నెంబర్ ని మనం ఇస్తే ఆ న్యూమరికల్ నెంబర్ డిలేకి యూజ్ అవుతుంది. ఫర్ డిలే వీ వాంట్ గివ్ సమ్ న్యూమరికల్, ఒక 100 కానీ 1000 కానీ లేదా 10,000 కానీ, డిపెండ్స్ అపాన్ యువర్ విష్. Okay, so that is only reason to write void. I mean that function definition is to give some delay. This is used defaultly for every program. మనం ఫ్యూచర్ లో మనం కమింగ్ క్లాసెస్ లో మనం చూడబోయే ఎవ్రీ క్లాస్ కి డిఫాల్ట్ గా దిస్ వాయిడ్ డిలే ఫంక్షన్ డెఫినేషన్ విల్ రిటర్న్ ఫర్ ఎవ్రీ ప్రోగ్రామ్. ఓకే, టు గివ్ సమ్ డిలే, అంతే. ఫర్ టు గివ్ సమ్ డిలే we are writing this function definition. That's what I understood and that's what I'm conveying for you. Okay, here in this for loop you can give whatever the number you want. If you want to give 10, if you want to give 100. Okay, if you increase microseconds, like 100 microseconds or 1000 microseconds, some numerical value, so that much of delay will be there. Okay, I will show you while running the code. I'll show you while running the code. Okay, man code run చేసిన తర్వాత output చూసిన తర్వాత we will see now. Okay, fine. And this is the code for LED blinking. I hope it's clear for you. I'll go to the skill again, open the project, new microvision project. Again going to kill in this LED only. I want to save, I want to make it as LED, not LED. LED. Okay, let me make LED. Okay, whatever the name you choose, it's your wish. 8089C51. This is our microcontroller. Double click on this. I'm just explaining you for the second time. Okay, click on this target one, go to file, click on new, again go to file, save it, as led.c. okay, whatever the name you have given to save before, with that name you have to give .c extension because we are writing a code in embedded C. Clear? Save it. Okay, and we are eligible to write a code. Before writing a code, add existing file. This is our LED. Add, close. Okay, click on this led.c. Okay, fine. let me copy this total code. Hash includes reg51.h, control C and control V. Fine. Let me check once whether there is an errors or not. Fine. Let me build this. So here we got 0 errors and 0 warnings. If you got this, go to this target one, right click on this target one, options for target one, try to change this clock frequency 11.0592. Okay, go to this output, create hexa file, click on, you must create this hexa file, click on OK. Again, you must go ahead with this hexa file creating hexa file. Fine, open your Proteus, my task is done. And again, I just want to double click on this microcontroller. Path plays a key role. Here they are asking led.hex. This is our hexa code, right? This is our hexa file. Click on this, open. So obviously the path is created. Click on OK, run this. So if you run this, initially the LED is off. Again it start blinking. Okay, ala off ayi malli on and off and malli. So if you make so guys, if you observe, ఇప్పుడు మనం చూద్దాం. ఇప్పుడు delay, I mean that function definition వల్ల use. So I have given like 100 for integer j, for 1000 for integer, 100 for integer I, 1000 for integer j. Let me change the values. Let me change the values because we will observe the change, right? So if మనం 10 ఇద్దాం ఇక్కడ, 100 ఇద్దాం ఇక్కడ. It's our wish to give some delay, some numerical value we are assigning, we are giving in the function definition, right? Rebuild this. If you do any changes in the code, you must to rebuild this. Okay, don't forget to rebuild this. Okay, go to this Proteus and try to run this. Guys, if you observe, the blinking is changed. Okay, and remember this, and there should not be exact delay. ఎగ్జాక్ట్ డిలే అయితే ఖచ్చితంగా ఉండదు. ఇప్పుడు మనం అబ్జర్వ్ చేస్తే ఎట్ ఒక 30 సెకండ్స్ లేదా బిఫోర్ 1 minute 30 సెకండ్స్ తర్వాత ఎగ్జాక్ట్ డిలే అప్లై కూడా అవ్వదు. ఓకే, ద ఎగ్జాక్ట్ డిలే విల్ బి అప్లైడ్ బై యూజింగ్ టైమర్స్ అండ్ కౌంటర్స్ కాన్సెప్ట్ which we discussed in last class. Fine. So try to change the values. It's actually you can play with this, right? Try to change the values like 100 and 1000 or 10,000, something like that. It's your wish, guys. If you do any changes in this skill, you must rebuild this. Go to this Proteus 8, run this. So that's it. Ardhavainda. If you have any doubts, you can ask me in chat box. I'll respond for your questions. Guys, అర్థమైందా? ఆదిత్య, are you there? Yeah, you are there. అర్థమైందా? Have you got my point? Yes. Guys, అర్థమైందా? Are you following or doing parallelly along with me or not? Yes. So next task is like I will make 2 LEDs. We'll make 2 LEDs. Okay. Fine, guys, let me go ahead with this. Let me go ahead with two LEDs. Let me go ahead with these two LEDs. Again, go to this. Sorry, go to this component mode. Okay, go to this component mode and take another LED, like type LEDs, and let me take green. Let me take green. Select this. 1 second. Make this Proteus in stop. Okay, take this LED green. Okay, fine. Delete block. Go to this terminal mode. Ground. Fine. Fine. I have taken common ground. Let me do a small changes. I don't want to change any path or like that. In this hardware part, we connected extra LED called LED is equal to LED1 is equal to, we connect for port 2 pin number 1. Fine. Is there any changes we want to do here? White delay LED is equal to 0, and here we have to change it LED1 it becomes 0, and then we have to give some delay. Okay, after this line we want to make LED 1 should be 1, then fine, we want to give some delay. So guys, this is the only change. Fine. Just checking any errors or not. Fine. So try to copy this total code. So if you observe, there is no change in the function definition, right? I'm just, in place of this, I'm just pasting this. Okay, fine. Let me build this. Let me rebuild this. Okay, the hexa file is created. Okay guys, I'm not changed any paths or like that. Aim change ledu. I just connected extra LED and there is a small change in the key. Okay, yeah, it's working fine. So guys, there is a task for you that try to connect 3 LEDs. Try to connect. 1 second. 1 second. Screenshots are mandatory for us because fine. So guys, try to this is a task for you. Complete it within 5 minutes. Complete this within 5 minutes. and I'll share you, I'm going to share you a link, a Google Sheet link. Try to fill this. One second, give me time. Guys, are you following? అర్థమవుతుందా? Are you following? One second, stop sharing, open the Chrome, Google Sheet. So name, college name, no college, registration number. So college name and mail ID. సడన్ గా ఇలా మైక్ ఆన్ చేస్తే నాకు భయం వేస్తుంది అనమాట. ఐ టు యూజ్ ఇయర్ ఫోన్స్, రైట్? మెయిల్ ఐడి, కాలేజ్ నేమ్, నేమ్, రిజిస్ట్రేషన్, మొబైల్, డిస్ట్రిక్ట్. ఎస్, share this, batch to a, save it as restricted meters, copy link, done. Guys, fill that sheet. So meanwhile, you want to do this task as what I have given for you, what I assigned for you. Okay, I'm going to give you the, I just want to pick one guy and I'm going to give the presenter for you, and you have to share your screen what you done. Okay, so evarna faculty unte, so if any faculty is there in the class, in bracket you can keep faculty. Okay. In place of name, after completion of your name, please keep that faculty something. In bracket you can keep your faculty. Okay, if faculty is there in the class. Okay, ardhamainda, class ardhamainda, that is most important. Guys, have you got my point? Are you following or not? Could you please respond in chat box? Guys, please do the task what I have given for you, and I'm going to give the presenter for you. I'll check that whether you are following or not. I don't, guys, is there any exams for you? In the exams జరుగుతాయి, గ్రూప్ లో 250 మంది ఉన్నారు, 20 మంది ఉన్నారు, అది అర్థం కాలేదు. What may be the reason? Is there any problem with the timings? Practicals, which we have practical. Okay, okay. Task చేశారా? Can I pick anyone? Shushma, have you done this? Have you done with the task? Guys, don't change some like నేను ఎడిట్ ఆప్షన్ ఇచ్చాను కదా, అందరిని don't edit that, okay? Don't disturb other names. Have you done the task what I have given? రెండు సార్లు ఎందుకు నన్ను ఇక్కడ ఎవరు? సత్య సౌందర్య. You have written 2 times. Try to change it, guys. Give me a second, I'll be back. So meanwhile you have to complete the task complete చేసాకే no చేయండి. Yes, okay. Raviteja, have you done this? Okay, can I give you the presenter? Can I give you the presenter?